all of that 4 years has been working with contractors to understand what are all those things that are not in any code book, in any spec sheet, that really inform why you build things the way you do. And we need to be able to take that field expertise, package that up into this AI system so that it can do that. It can start to produce designs, and it's applying all of that same thinking to that you are when you're drawing those lines on the screen, or you're extruding that piping, or conduit, sorry, in Revit, and gets you designs that you can actually build with confidence. And if we can do that, and if we can take the time it takes to do that from 200 hours down to 20 hours, suddenly the nature of the design process has changed, and you can start to use it in radically different ways.
On this week's show, Sparking Design Automation with Aaron Szymanski and Francesco Iorio from Augmenta. All right, Jonathan, we dorked out last night. Now we're going to dork out again. I couldn't think of anybody better to jump on this one with me. How you doing, my man?
I'm doing really good. And I want to be on this one because, I've been watching this product for a very long time. Like it has been the leader probably in the AI layout from my standpoint almost since the first time I saw it. So it was really nice to Aaron to talk to you again, Francisco to talk to you again. And Jeff, I have finally had a day where I woke up and went outside and it is not like freezing when I do my morning walk. So beautiful day, beautiful time to have a discussion, and and great product and to talk about.
Well, that's a great introduction. Aaron, thanks for sitting down with us today and joining us on the show. Where are you coming at us from?
I'm coming at you from Toronto.
Toronto, that Canadian. See, we're building that American Canadian relationship here. I'll leave
Yep.
that jokes for later on. We'll hit that later.
That's for a different podcast, I think.
Who knows these days? Francesco, it's great to see you. Nice to meet you. Where are you sitting down with us from today?
Same thing. Actually, I'm in Toronto as well.
All
Oh,
right.
awesome.
So we got another Toronto team on with us. You guys are going to want to stick around. As Jonathan already said, we were excited that these two were ready to come on the show. If you want to see the show, you want to go to youtube.com/at thecontechcrew.com. And if you're not following the ConTech Crew on LinkedIn, you're going to be missing out on some of the new stuff we're doing. Maybe a few new promotions, a few new things coming your way. So make sure you follow us there and stay up to date. Are you trying to reach the innovators and decision makers in construction technology? Then look no further than sponsoring the ConTech Crew. That's right, we're taking new advertisers. Email us at advertising@thecontechcrew.com to learn more. All right, so Augmenta. We've been hearing about this now.
Guys, help us out. Is it 3 years?
It depends on when you count, or when you start counting.
That's right.
It's probably been about 4 solid years of us working on this problem.
And I do have to say that was probably the most impressive thing when you came out is you got the problem right. I think there is a lot of excitement around this idea that we can run routes using automation, but a lot of people, when they show off, like within 10 minutes, you're like, you got the problem wrong. You don't know, like I can do that. What I can't do is, and I think that was part of what really turned me on to your project. But I wanted to ask you before we get into that. I got obsessed with your product, so I actually didn't ask you about yourselves at all when we were talking. Aaron, maybe start with you. Like, can you give us a little background and how did you decide to get involved in this?
Sure. Yeah. So I've got no background in construction whatsoever. I'll just start with that. My background was originally in industrial design. I used to work at BlackBerry and I designed Blackberries. So I designed
Cool.
phones and tablets and things like that. But as I was working there, I very quickly realized I was a lot more interested in the screen, the magic that was sort of happening in that little rectangle as opposed to the object itself. So I quit my job as an industrial designer and I moved into digital product design. And what I was really interested in was finding new ways to interact with computers and really trying to push the idea of what computers can do for us beyond just serving up, clothing or offering up social networks and things like that. So I've always been really interested in sort of advancing the state of the art of how people interact with computers and really more importantly, what they're using them to do. And through that, I met with Francesco. So Francesco, I'll let him sort of give some of the background, but the one sort of key point of overlap that led to Augmenta was that we worked together on a little project called Dreamcatcher at Autodesk. And Dreamcatcher was the very first instantiation of generative design. And that'll be sort of the little hook that I'll pass over to Francesco. But that's really sort of where Augmenta started. And that was probably way back in 2015 or so.
Yeah, no.
So if you really start counting, we've been working on this as a problem for a very long time. We've been thinking about sort of how computers can solve extremely complex problems, even outside of construction, but just more generally for a very long time. So it's really been quite a long time coming. But I'll pass it over to Francesco maybe to fill in his part of the story.
My part of the story is that I probably have less like a construction background than even Aaron. So I'm your standard nerd.
It's true.
So
I
so
built
I,
a
I
shed once. I did do
yeah,
that.
it's true. Yeah. Well, there you go. So but yeah, I mean, I am from computer science, right? So I've been software developer all my life. In fact, I actually started with video games development. It was a long time ago, my first career, right? So, but I worked on computers of very different types of sizes, right? So especially like very big ones, like the ones that take like a whole floor of a building, right? So so-called supercomputers. So what happened is that I was working at Autodesk for a while, right? So and while there, I realized what became essentially generative design, right? So, and this actually was kind of a spur of the moment realization when I went to a manufacturing fair that exhibited one of the very first multi-material 3D printers. So you can imagine kind of these machines were prototypes, right? So with like multiple nozzles and stuff, right? So, and what fascinated me was that, okay, if you thought about it in perspective, you could think about, okay, this is a machine that given a specific a volume of space, it can put whatever material you want anywhere you want. And therefore, how you're going to choose, how are you going to make a decision of which material goes where in order to do what you want? And it becomes a type of problem that the humans are actually kind of very ill equipped to solve. Right? We scarcely are able to actually think in 3D in design, if you think about it, right? So, I mean, how long it took actually for us to to move it on a drafting table to, AutoCAD 3D. I mean, amazing, right? So, so imagine actually this complexity of having, a continuous space of materials. So that really kind of, started my journey that became generative design, right? So that started this whole process. And again, while it was actually working on this concept, again, I am the nerd in your dark room, right? So for me, design effectively, doesn't exist, this mythical beast, right? So I happened to meet Aaron at a friend's wedding. I mean, of all places, right? So yeah, so and we started chatting, and I realized that he had a lot in common in terms of kind of thought space, right? So as in, we were all thinking about that. Tools and instruments are very limiting, are limiting the creativity, are limiting how people can express their intent, right? So and we were trying to kind of reverse engineer what you have to do in order for a computer system to be your partner, your actual partner, right? So and honestly, like we picked the name of the company actually out of that kind of whole shebang, like if you will, right? So and that's really kind of what originated, Project Dreamcatcher, and then kind of everything that kind of fell actually after that, right? So, and then our journey to into AEC kind of started essentially by realizing, how much the construction industry actually needs design automation more than many other fields, if you will.
Oh, very much so. When you were, so I remember seeing Dreamcatcher at AU, and at the time I was, I actually think I was an engineer still more than I was a contractor, and that was blowing me away because now a lot of the calculations that we were going to do to figure out rooms, it looked like this was gonna win. And at the same time, I think that same year they were really big on cobots and sort of human robot interaction was some of the sort of workshops that were offered. So how how in the world Did you go from it was mostly like a room layout and like interior design when I saw Dreamcatcher along with some other design, but from an architectural standpoint, it was more that. How did you go from that to where you are today? Like, was there like a giant stepping off point, or did it actually evolve from the other?
So, well, I mean, the focus actually of the Dreamcatcher effort actually was mostly on mechanical engineering, with actual like aerospace manufacturing, if you will, right? So that's kind of where we started from, right? So architecture was kind of a, like kind of a side project, if you will, right? So the challenge is that in manufacturing, again, generative design kind of started teaching people that physics and intent matters, and it's a design is a realization of that intent, right? So that is the thread that persisted when we started actually looking into architecture and construction, right? So, and again, very quickly we realized that the distance in digitalization, really, the distance between pen and paper and realization in construction, which is so colossal, even relative to manufacturing, right? So, and so that's really kind of what started this thought process that led it to to us leaving the firm and then kind of starting Augmenta and actually kind of taking this grand challenge.
Yeah, I'll add to that a little bit. I think, we sort of realized that the way the ideas we had were manifesting there were short of what they could be. And this podcast is about Augmenta. It's not about Autodesk, so I'll leave it at that. But I think when we started Augmenta, we didn't even necessarily, it didn't have to be construction, but construction was obviously a really good fit because fundamentally what we realized we had was this is an approach to solve any multivariate problem. These are problems where some human being has to find a way to balance hundreds or thousands of different variables. And that's what every construction project is. Maybe you do it once at the start and then you're building the same thing over and over. But most of the time, every building is effectively a perfect or a unique snowflake, maybe not a perfect snowflake. And you have to go and in that process find some unique optimal balance. And the problem is that in reality, you don't usually, right? Like the thing gets built, but it's probably not the best it could theoretically be. And architecture is just architecture in that that's construction, not just architecture, is really the probably the best example of that type of a problem that we all deal with on a day-to-day basis. It really is the thing that covers the entire planet. That is the whole built environment. So if we kind of think about um, that type of abstract problem, we have a technology that can solve it. Where should we aim that? Well, it's probably going to be construction. Maybe there's other fields. Medicine is a really good one. There's finance, but we didn't want to work on finance. So it sort of seemed like this was a really good fit for this fundamental approach. So anyway, I'll leave that there.
Yeah,
But
no,
it's sort of like the nature of the problem matches really well with sort of the fundamental capabilities of these types of approaches.
You know this better than me, right? So again, it's the problem that Aaron just mentioned, right? So buildings generally are designed once and built once, right? So the design issues is exacerbated, right? So in manufacturing, even medicine, right? So you can spend years over years of engineering time or scientists that they can toil away at something that then you'll sell millions of, right? So or tens of thousands, or essentially a variable amount, but you can amortize, right, the cost and the effort and the blood, sweat, and tears of your teams, right? So across a large variety and like spectrum, if you will, right? So whereas in construction, that's kind of hardly ever the case, right? So, but I mean, there seems to be reasons for that, right? So people don't want to people don't want to, live in an iPhone standardized kind of living quarter, if you will, right? So, or work in a standardized. So, modular manufacturing has a place, of course, but it doesn't seem geared towards solving all of the built environment, right? So and so the problem remains, and so something that can help with that actually seemed very appropriate.
Yeah, you guys hit on a couple of things there that are interesting because it is the problem is the amortization. People don't understand that one of the reasons we haven't reached digitalization and sort of the return on investment that everybody loves to talk about is because we don't have that repeatability over time to then spread that cost out and take that time. But also, look, we don't take the time to plan, right?
Yeah,
Like,
yeah.
at least in the manufacturing space, of rigor you're going to go through before you put something to production. And you also know you have constraints of production. So that gives you constraints on materials. we don't like the word constraints when it comes to materials or what we build or how we're going to build it. But I love the fact that you're talking about balancing variables and using the machines to do that because how many times, John, you know this, before the walls go up, you walk something and you look and you go, eh, why did we do that?
Yeah.
You're like, and you're like, well, because like this person didn't talk to this person, or
Mhm.
we're really bad at like millions of variables and picking the right one in the end. So talk to us a little bit about, how you've moved on down and where you are sort of today with solving these problems and
Mhm.
helping people with that issue.
Sure. So I'll take a pass at it. Francesco can add to it. Maybe just a quick statement on where we're going, and then I'll talk about where we are today. Where Augmenta is going is Augmenta is on a mission to completely automate the engineering and detailed constructible design of entire buildings. That is a long-term plan. We will get there in steps. Our very first step is to really start at the end, right? We're starting off with the ability or automating, let's say, aspects of the process of designing something that can actually be built. And within that, we've started with electrical. So really overall, we all know this, the systems, the things that you can't see when you're in a finished building. I've got a bunch of bulkheads behind me. The things that are in those bulkheads, that's what makes buildings really complicated. And that's really where we've decided to start. So within those, we're really starting with the three key trades, the mechanical, electrical, plumbing sort of system types. Within that, we started with an electrical simply because electrical, really two reasons. The contractors are often starting with the least from a design model perspective. So they have to do the most catch up. There's a real need for something like this there. And also, they tend to move around the most. They kind of get pushed around the most, unfortunately, during the coordination process. So there's really a gap there that we can help to fill with a tool like this. Okay, so what is that tool? So what we've built is a AI agent that automates the routing, the modeling, the coordination of raceway systems. And what it does is it does this in a way where it's not just a simple, quote unquote, dumb point to point router. It is actually really understanding that building. It's analyzing the building that you want to route that system in. It's looking at what are all the other systems that are present in here. What are all the surfaces that I need to support off of or can't support off of? What are all the walls and various elements that I can or can't penetrate through? And it's applying a lot of intelligence. And you asked, how long have we been working on this? 4 years. All of that 4 years has been working with contractors to understand what are all those things that are not in any code book, in any spec sheet that really inform why you build things the way you do. And we need to be able to take that field expertise, package that up into this AI system so that it can do that. It can start to produce designs and it's applying all of that same thinking to that you are when you're drawing those lines on the screen or you're extruding that piping, or conduit, sorry, in Revit and gets you designs that you can actually build with confidence. And if we can do that, and if we can take the time it takes to do that from 200 hours down to 20 hours, suddenly the nature of the design process has changed and you can start to use it in radically different ways. So that's really what we're trying to do. In terms of where we are today, that's where we started. We've built out our first electrical product. We're really just coming into the market this year. So we've got our first projects done now, more actually in the field being built using our technology. First contractors using it. We're focused on overhead conduit only. So we're kind of taking this even there step by step, overhead, then underground, then in wall. And at the same time, we're starting to do some of that early work around really building out the same type of workflow for mechanical and plumbing as well. And we have some really cool ideas that I hope you'll ask us about there. But that's really where we're going next.
Yeah, before we jump there though, because I hear 200 hours to 20 hours. We've been doing this long enough. I hear somebody go, "Oh, cool, I can cut people." No, but so when that 200 hours to 20 hours, like, what is then the work the person is doing
Yeah,
in that process? That's what I want people to hear.
sure. Yeah. So we can get into the details of what that actually looks like. So the way the system works is just to make it very, very clear for everyone is it starts off with a Revit model. So I'm a contractor. I'm the BIM modeler. I just won this project. I have to get it populated. Okay. I have my Revit model that I got. It's got the architectural, structural, mechanical, plumbing, whatever is available. I've got that linked in. I'm going to place my equipment in there. So my panels, my junction boxes, and so on. Those have some kind of a unique ID. That's my panel name, my fixture name, whatever. And then I'm providing a description to the system of what I want to connect. This panel has to go to this home run box with 3 1-inch conduits, right? I'm providing that description there. In the future, we'll actually move upstream of that. But today, that's really what you're doing. You're effectively taking all the things that you would know at the start of a project because you're seeing it in the one lines. Maybe you're seeing it in sort of the preliminary plans or markups from your planning team, and you're inputting that into the software. You're inputting your project specs. What type of supporting methods do I have? What are the clearances? What are my heights and so on? I'm just defining the problem. I hit generate. The system creates a fully routed design. So if I'm doing a hospital, I set up that schedule for the whole hospital, and I'm getting a fully populated hospital back. That actual generation process is actually fairly quick. So most of the time is in that initial setup. There's iteration, right? You're going to see it generate something. You say, oh, shoot, I forgot to mention there's a riser here. You're allowed to punch up through that. That's why you're going all the way around the building instead of just up the center, like I would like you to. So you're sort of working with the system. So there's a bunch of these cycles that happen, and we are not producing perfect designs, right? We're kind of at the point where, if you remember, Mid Journey, there's this extra finger on that hand. Hey, I caught that. I need to go into Photoshop and fix that. That's where we are today, right? So we are outputting designs that need to be edited. Like there's extra bends that probably shouldn't be there. There's some self collisions and things like that. But generally, what we're seeing is today, from total a real world performance perspective, if you take the time to do that setup, half of which you'd probably be doing anyway, generate some results, edit that result. On average, we're, as of March 14th, 2025, at a 48% reduction in the time that it would take compared to modeling manually. So pretty significant. We'll get to that 10x where it's 200 to 20, but even today it's pretty significant. And we've made big improvements. So if we were having this session 6 months ago, last summer, that would be, 25 to 30% speed up. So we've got a really good sort of rate of improvement, and most of that's just coming from fundamental improvements to the underlying model that's creating these solutions.
Yeah, I'll just add two words as well, right? So, and about the balancing act that you were mentioning before, Josh, right? So as in one of the big balancing acts is to ensure that the system kind of considers, on one hand, what a foreman would do, and on the other hand, what the machine would do. And that's a kind of a careful balancing act, because the machine could actually try something that is maybe uncomfortable, or that is kind of maybe weird for the person to consider, right? So, but maybe it's better, right? So, and so we are trying to straddle kind of that line where, something is like a familiar, if you will, that looks familiar, or that does best possibly, right? So, and they're not always coincidence, right? So, but that's one of the beauties of having this, again, this virtual group of folks behind the screen, right? So where you can see them all, right? So you can understand like why it thought that maybe doing something instead of something else actually made sense, or maybe it didn't make sense, right? So, but it offers, it's a methodology, right? So it's not just a design tool; it's really a design methodology. The artificial intelligence is really interesting and peculiar because, again, we're trying to capture that set of unwritten rules, but at the same time the written rules, right? So the laws of physics, the actual cost and the time it takes actually to put these systems together once they're designed, right? So it's a kind of it's always a balancing act.
And I would definitely point out that with VDC technicians, the people actually doing it, it takes 4 years before you're relatively good, and then probably 7 years before you're actually like really kick butt at this. And we're still not right, like for sure. And we only have so much context we're dealing with when we're in VDC. We don't have like dynamic understanding of what's going on in that building. We have very static understanding. And I that's why, when you said you started out with the mechanicals, I was impressed because really the mechanicals is that balancing act that is tension that you can really address really well with AI. AI is really well at looking at statistical tension and picking what's best or what's most interesting. And I will also tell you all those new things that no one's ever tried before. new VDC technicians, when they sit down, will try all of those with us. Again, thinking back, you're like, hey, we're on a 4-year journey. Quite literally, everybody out there that's in VDC, go out and look at your 4-year apprentices. And, I mean, there's still a lot to learn there. And I'm sure you guys have it too. I have a question on context. Really do. So one of the neatest things that you must have had to do is try to figure out what's important for the building to understand or to relate back to what you're laying out. Have there been any big surprises there that really shocked you? It's like, I didn't realize that we were going to have to take this into account as we're doing routing, or has it been pretty obvious from talking to foremen and looking what's going to be important?
So I'm thinking about how to answer this because the
Yeah,
answer is
same.
actually a little bit more subtle. As in, we from day one, literally from the day we founded the company, we had a design partner already. This company has never not been partnered intimately with VDC teams across multiple contractors, and I think even in the first month of our formation, we were already on site and spent weeks on site with the VDC team of one of those partners. So that was good for us because we all came from software, so we had no preconception of what was reasonable, what wasn't, and so we sort of learned from the ground up in that way. But I mean, certainly at the more subtle level, there's a lot of work that we're doing to really understand actually what is the context that we need from that model, right? If you look at a BIM model, putting aside the modeling issues themselves, which are their own headache, I don't even want to get into it. Just keep too many lost nights thinking about that. But more interestingly is that there's always things that you know about that project that the BIM model does not. You know which walls, these ones I could penetrate through. Hey, even these are the fire rated walls and these ones are not, and that's not in the model, but it's in the drawing. Someone colored it in a separate PDF where they put an arrow with a little cloud, with some text in it and things like that. And that's the type of context that our system needs that isn't actually all that easy to get. We have to find ways to pull that from different sources or have ways for the user to represent that. And so a lot of, I think, the things that we're doing that are quite interesting more from the user experience perspective is finding ways for people to express, here's what I know about this project that you would not know just looking at the model or even any drawings that need to be aware of to produce a solution that I think is reasonable. Because if you don't, our system will always try to find a way to route all that stuff together, but it's just going to produce it in a way that you look at and you're like, that's not what I want to do at all. Because you didn't realize that there's a riser here. A riser is not a concept that exists as a Revit element, but it's a very real thing, right? To say people know, oh, these are the floors I can punch through. Again, that's not a Revit element that says that, but the user knows that. So we have to find ways to kind of have you sort of have a conversation with the system and sort of tell it what you know about that so that just like that junior modeler, it's going to do something that you expect because it has the same context that you do.
And I love that. You had I don't know if it's continued or you automated, but you had the go, no-go zones,
Yep.
that allowed, I mean, because you're exactly right. And I also have put pipe in a place because I know that there's a scissor lift that I can get to on a
Exactly.
regular basis after the job's done. And there really does need that context will never be something that's easy to pull back
No
as
one's going to
data.
model that. No,
Yeah.
no.
So giving us that, and I think you found out when you were on site, when people are actually planning and you're stick building a building it on site, we usually are like, okay, you're going to go high, you're going to go low. We're going to, and we do that basic giant rectangles type thinking about areas where we come together. And I remember seeing the no go and go zones and I'm like, oh, so after the meeting, I go back with these rectangles and I'm like, oh, that's brilliant. That's exactly how we actually plan. We just don't get into the detail. And usually what happens is when you get into the detail, you find out the rectangles need to be in a different spot, but it takes a long time to figure that out. So if you guys can get that through, that that time you save in VDC is one thing, but that time that you save because we didn't do something wrong, I think that's even better because we can look at those areas and say, nope, it's laid out. It doesn't look good. We're going to move it. I liked that when I first saw Dreamcatcher too. It had like, here's 20 things to choose from. Let's go do it.
Definitely.
Jeff, do you have something? I keep cut. I will take up all of the oxygen with these two so easily that
I wanted actually to go back to a
I
question that
love it.
Jeff asked
Yeah, I
before,
would like
though.
to do
So
that too.
if you
oh,
don't
okay.
mind, like, as it's just no, no, if you don't mind, it's just that there was actually kind of a key point that we kind of glossed over a little bit, right? So, and you ask, when you actually cut, 200 hours to 20, does it mean that you're cutting the 200 people to 20, right? So effectively, right? So as in, you know what I mean? So, but it could not be farther from reality, right? So as in every day we talk to folks in the industry, right? So contractor GCs, like everybody, right? So, and everyone laments, the scarcity of skilled talent, right? Like, as in, not one single partner, design partner, customer, right? So is planning to use this technology to displace people, but it's because they don't have enough people, right? So, like, it's a real problem, right? So there's not enough outsourcing they can do. There's not enough hiring. There's not enough training. There's not enough anything, right? So they're trying to keep up with the demand and the complexity, of course, right? So it's definitely a supplementary boost that this system is actually designed to provide to BDC teams, right? So by no stretch of imagination is a replacement.
I actually think you're adding because we talked about it on the Dorks last night with Hugh Seaton. You brought it up. It's teaching. You're going to co-learn with that system. If you're an early designer, if you're somebody that maybe you shouldn't be in the VDC seat yet, but with that force multiplier of Augmenta, now you can be.
I think it also is this opportunity. We talk about it over and over and over. Not enough time to plan, not enough time to understand, not enough time for all of those trades to come together, either to work on the vision of the asset owner and what they actually care about, right? We spend more time drawing lines and pulling things and fighting over space and squares than we do talking about value, talking about opportunity, talking about working together, doing those things. So I always see it as that. And by the way, I mean, watch the job boards. If you're in BIM and you need a job, there's you're not going to be waiting for long, right? There's just not enough of. I don't know one BIM and VDC department that's not like, oh, another person. Yeah, no, I don't need them. No, no,
I'm
not
pretty sure
unless
there's
you're
more
just
postings
fighting
than
BIM.
people. Yeah, yeah.
Oh yeah, that's 100%. And you're I like the force multiplier, John. I like that ability to we've talked about this, and Josh Bone from Electri talks about
Yes,
it a lot, right? We've
of
got
course.
to democratize that information. And a model like this, I imagine, as you're working in Augmenta and you're giving it those up front, then you're training it, then you're changing things, and you're saying, hey, we did this instead of this. This is what I would do. It's learning,
Yep.
and it's going to consistently learn you, consistently get better, and probably start offering up ideas. Oh, you've done healthcare this many times, and in the ICU in this situation, this configuration has not only been your choice, but we've proven from construction that it's been valuable to the asset owner and to the schedule and to this. Here you go. So I could see. So that's what I want you guys to do, because we're getting close to that end. Um, as you because by the way, also, guys, if you don't have a healthy respect for these two at Augmenta saying we want to be all those things, but we're literally just going to do electrical right now. And oh, by the way, we're going to do overhead only. You heard them. We're not going in the wall. Coming from software, that is a real hard rigor to hold on to, because I would love to eat that entire cake in one bite, but we know where that's going to end up, right? And so kudos to you guys for doing that. So now I want to offer you okay, money doesn't matter, time doesn't matter. Where do you see this being able to go in the long run? How is the world of construction going to change because of tools like this?
Don't even know where to begin. It's gonna be a long journey, again, to your point, right? So again, we're taking it very kind of humbly. We realize that it'll be a long time coming, right? So as in the opportunity is really kind of, limitless, right? If you think about it, the certainly part of our vision is to ensure that people who are in decision making kind of seats, if you will, and all, have the opportunity to have that information available to them, right? As much information as possible, right? So, and you can see, like, in extremely linear projects like construction, right? So some information doesn't exist until it's way too late, right? Again, because there's not enough time to do planning. You don't really have, I mean, there are some projects, the tip of the spear, that can spend, 3 years just in planning and design and architectural space because they can afford it, right? So yeah, it's the next, mega tower in Dubai, great, right? So, but and even then, right, they're always in a hurry, no matter what, right? So, but at least they can afford the time to put, an engineering team, design team for a long time, right? So, but that's generally for the 99.999% of the buildings, it's just not the case. And so that's where things actually break down, right? So that's where the information, the precious information, it appears way too late. And so we think that the opportunity going kind of far forward actually in the future is really to bring a lot of, it is bring reality fast at the fingertips of the people who make those decisions, who specify that intent, really, right? So, and so at the beginning of the project, if you have the ability to understand the compromises that you're making, right? So like quickly, but how they translate into reality, into something that you can actually procure and build at the level of the entire building, right? So that is really kind of what the opportunity truly is, right? So as in, imagine kind of what that would be like, a meeting of stakeholders, right? So the engineer, the consultants, everyone, right, can all sit around a table, right? So and express their requirements, express their intent as such, right? So and literally have a conversation about it with a system that returns options, right, in real time, or as real time as possible, as to what the consequences of those thoughts or opportunities actually are, right? So this is the design methodology that we're talking about, right? So that is going to be a leap, like a leap forward, that that transcends the nature of computer aided design, if you will, right? So it's a very different process, right, at that stage. But that's really kind of where we think this is, in the fullest of time, right? This can
That's
go.
that was the opportunity I gave you, was to go all the way out there. Aaron, any thoughts on your end from all of that?
Yeah, the way I always think about this is that, if you make something twice as fast or twice as cheap, it's the same thing that's twice as fast or twice as cheap. But if you make something 10 times faster or 20 times faster, it actually changes in a very fundamental way. So if you could basically take the detailed construction design process and make that free. Imagine it was free. Imagine it was instant, and imagine it didn't cost you anything. Where would you use it and who would use it? How would a GC use that? How would a contractor use that? How would an engineer and architect use that? That's really what we're trying to do. And we want, like Francesco mentioned, to make it so that I can take a napkin sketch of a building, or I can take a pro forma, or I can just take a desire for a building to exist and immediately see what that means and see what those trade-offs are. And I think what it's going to do is sort of really change the role that different people play in the process of building a building, in I think really interesting ways. But fundamentally, what it does is it just democratizes the ability to create the design of a building or a system in a way that can be built. And I really think that that on its own is just going to fundamentally change the way the industry operates, because today that is in a way really a fundamental bottleneck. It's why buildings are so hard, right? It's because they have to be replanned from scratch every single time.
When we look at DFMA, the number one thing we want to do in DFMA is take virtual design and construction that happens at the point of build, usually sometimes when the building's actually built, and move that back into early design when the
Exactly.
cost of a change order, when the cost of a change order is next to zero. Like our ability to impact from a cost standpoint really changes when we hit bid documents. I mean, there's a huge change.
Yeah,
And if you guys can give us detailed design before that, the overall expense of buildings is actually gonna come down. I
they
mean,
will.
you it's not even like, there are many graphs, I'll send you one for DFMA of like, "Hey, all we have to do is get it this far back in the process, and we can see amazing savings." So really excited, really
If you
excited.
want to learn more about what John's talking about, you guys are going to have to come see us on stage somewhere. To the folks listening in, because John's DFMA design for manufacturing and assembly is a phenomenal, it is the holy grail of where we have to go, but it's a truly fundamental process change, which is what I like that you guys both said. It's going to be done incrementally along the way as the tools get built, and we can get that, that 10-20% increase, 30% increase, 40% increase along the way. So you're getting incremental, but at some point, it's all flip and we're going to actually change the process in general. So when you hear us all saying on the show and you hear us on stage in places saying in 3 to 5 years, construction's not going to look the way it did before, that's what we mean by it. And I think I'm excited that you two got to kind of bring that to us. I got to wrap this thing up. Francesco, thank you so much for sitting down. Aaron, thanks for sitting down with us today.
Thank you for having us.
Absolute pleasure.
Let people know where they can go find out a little bit more about Augmenta.
Absolutely. Best place to check us out is on our website. You can reach us there. So that's at www.augmenta.ai.
And also on our LinkedIn page.
Follow them on LinkedIn. Jonathan Marsh, always a pleasure to sit down with you, my man.
Great to be here, man.
And thank you for tuning in today to geek out for our interview with Aaron Szymanski and Francesco Iorio. To read all our news stories, learn more about our guests, and to listen to this show, visit thecontechcrew.com. This is the ConTech Crew signing out. Until next time, enjoy the ride and geek out.